Hello, everyone. We're going to get started here in a few minutes. Thank you for joining us. My name is Wade. I'm a member of the team here at Advanced Clustering. I wanted to let you know that everyone in this webinar today are going to be on mute so that we can get through the presentation, which will take about 45 minutes. Once the presentation concludes, we will answer questions, and you can feel free to, as the presentation is going along, if you think of a question or have a comment, feel free to make them in the chat window, and we will be watching those as it goes along, and at the end we will address them. I wanted to let everyone know that this slide deck and video will be made available after the fact. You can access that on our website, advancedclustering.com/webinar series, and I'll be sending an email about that as well. I want to thank you all for joining us today, and without further ado, I believe we will get started.
Hello, thank you for attending our Insider's View to ClusterVisor webinar. My name is Kyle Shoemaker with Advanced Clustering, and I'll be giving the presentation today. We really appreciate you taking some time out of your day to join us. With that being said, there's a lot to be covered, so let's just get started. So we'll start by going over the agenda for today's webinar. The main topics will be what is ClusterVisor, the features and benefits, a short architectural overview, and then spend most of our time in the live demo. So, what is ClusterVisor? ClusterVisor is Advanced Clustering's homegrown cluster management software. It was developed with our over 20 years of experience in supplying HPC clusters to customers and the feedback we've got from those customers. The main goal is to provide an easy-to-use interface to manage, monitor, and maintain HPC cluster systems, even for those that have never done it before. And since technologies and users' needs are always changing, we have a full-featured plugin architecture to allow for easy extensibility in the future. Some of the key features of ClusterVisor are that it will provide a full-featured web interface to manage your HPC cluster. We also haven't forgot about those that prefer the command line, as that option is available there as well. Any configuration updates done in ClusterVisor are automatically propagated through your cluster, keeping your system correctly configured. Customizable dashboards are available so you can easily see the health of your system and all the metrics that are important to you. Our integrated monitoring and statistic engine automatically collects metrics from nodes in your system like CPU usage, memory utilization, temperatures, and you can create custom alerts and actions based on those values. We provide a complete user and group management with a built-in LDAP server so you can easily manage accounts and passwords. And through our integrated cloning system, you can easily install new nodes to expand your cluster or re-image nodes after hardware failures or major OS updates and changes. Let's talk a little bit about the architecture of ClusterVisor before getting into the live demo. There are two main server components as part of ClusterVisor. There's CV Server D and CV Client D. So CV Server D runs on head node or a management node, and it provides the backend APIs for all other ClusterVisor components. It also orchestrates network booting of the compute nodes, and it interfaces into our databases, MongoDB to store the configuration, and InfluxDB to store the node metrics. Now we'll move on to CV Client D. This runs on all nodes in the cluster. Its main purpose is to collect metrics on the system, including CPU, memory, temperature, networking, RAID array status, and many more. It also receives updates from CV Server D to the system configurations, and it will implement those changes on the nodes. Just like the server side, there are two primary client components to ClusterVisor. There's the web interface and the command line. The web interface runs as a module to Cockpit, which Cockpit is an open source server management software that comes pre-installed on many Linux distros. Since Cockpit is already a secure, tested system for managing of Linux servers, it makes sense for ClusterVisor to plug into that instead of reinventing the wheel. So, because of our flexible architecture, the web interface can run on any host inside the cluster. Normally this is the head node or management node, but it isn't required to run there. Now moving on to the command line component. We provide a unified interface to all the tools to help manage and use the cluster. Some examples of these tools are cvconf, that will help you configure and manage the system, cvexec to run commands across all the nodes, cvstats to query the node metrics, and there are many more. Now, enough slides. Let's move on to the live demo. So for the demo, we're going to pull up our web browser here and go to the IP address of our head node on port 9090. And this is the default port that Cockpit listens on. So you can see we've got a CentOS 8 machine. Username and password, it's the same username and password that you authenticate to the host system with. So in this example, we're going to use root as our username, but you can actually log in as other users as well. And there is a full permission system that we'll go over in a bit inside of ClusterVisor that you can show certain details to some users, create other users as administrators, etc. So we're going to go ahead and hit login. So I'm going to go ahead and click here first. So if you're not familiar, this is kind of the main Cockpit screen that you would see by logging into a regular Cockpit instance without ClusterVisor installed. Just a little bit about our demo system here. It's running on some virtualized machines. So we actually have a head node and 4 compute nodes. But here you can see this is all the individual settings and configuration that can be done inside of Cockpit for our head node, which our head node's name is demo.cluster here. But you can see on the side that there is not only this tab for our head node, there's also a tab for ClusterVisor. So this is our ClusterVisor plugin. All you have to do is click here and it pulls up the main ClusterVisor interface. So a little bit of details of what you're seeing here is you've got all these different sections, which are the main sections and information screens inside of ClusterVisor. You can see we're on the dashboard screen. We'll get into some details of what you can do with this in a minute, but I think where we'll start first is in the configuration, because this is kind of how you configure ClusterVisor, you configure your entire system, and maintain your HPC system. So you can see in this main configuration screen, we have a whole series of tabs across the top. These tabs are the different areas that you can configure. So we have configuration, which is global configuration type stuff. So in here we have config.global, config LDAP, permissions, email alerts, cloner. So all of this is the main system-wide configuration. So if we look under global, we can see we can set the time zone, the domain name of our cluster, which host is the main CV server node, other information about paths to files, monitoring information, etc. So as I mentioned in the beginning, there is a whole permission system. So if we go ahead and look at this config.permissions, so you can see we have the option to create multiple admins. So if there's another user on your system and you don't want to log in the web interface as root like I did, you create the user on your system, click admin UID, enter the user information, and then that user will also have full admin privileges. You can also see there's a bunch of true false flags here, and these are all these individual pages on the side, and if it's not an admin user and they were to log in the web interface, what information would they see? So do we want to hide the dashboard? In this case, no. Do we want to hide the rack layout? No. But we do. You see, we do hide the boot and power control. We hide the configuration. We hide the users and groups. So we hide all kind of the system level stuff, but we still allow the users to log in and see what we want, stats and information about the cluster. So we'll move over to the main section here, where when initially setting up your cluster, you'll be using this node tab a lot. So this node tab is where you can define all the nodes in your system. Now, we realize that actually if you had a large scale cluster, adding 100 entries into this would be a quite tedious task. So what we've done is kind of shortened that, or made some shortcuts available to you that uses the same syntax that Slurm does. For example, you see this node.node01 through 05. So this would automatically, with this one database entry, create node 1 through 5 in your cluster. So that way you don't have to make node 1, node 2, node 3, node 4, node 5, because in reality, node 1 through 5 or node 1 through X in your cluster are going to share a lot of the same information. So that really helps data entry. It helps it easier. So if you want to make one change across all the nodes, you can click edit, make that one change, and you're done. Now there's a way to override some settings, and we'll get into that in a minute, but I want to talk about the couple of buttons that you see over here on the side. So we have an edit button, a plugin node, and copy. Edit and copy are fairly self-explanatory. The plugin is a little more information that I want to share. So if we click on plugins, what we see here is all of the different plugins that are enabled on this node. And the idea of plugins here are the individual services, config files, and things you want ClusterVisor to manage. So we realized when building this system that we would be changing the configuration files and types of services we would manage as time went on. So we built this as a plugin architecture. The plus with this as well is that if you as a system administrator have certain configurations that you want to maintain yourself and don't want ClusterVisor to handle for you, you can remove those plugins from those nodes. For example, like right here, we have this DHCP DNS server. So we manage that on this head node, head node called demo for you. If you decide, you know what, I have my own way of doing that, I don't want you guys to touch that, all you have to do is click here, disable the plugin, and no DHCP DNS stuff will be maintained anymore by ClusterVisor. Obviously, if you want the full feature set of ClusterVisor, you want to put most of the plugins in place, but it's kind of up to you depending on what things make sense. So you can see there's a couple of plugins that we don't have enabled. So we don't have the IPMI settings. Again, these are virtualized machines, so they don't have IPMI interfaces. But if they did, you could add that in, and we would fully manage the IPMI username, password, all that information for you. And then there's also the Slurm client plugin, which would allow you to run jobs on a node. So in this case, this is our head node, so we don't really need the Slurm client. But if you see, we actually do have the Slurm server plugin. So ClusterVisor also supports diskless nodes, and if you want this system to host diskless nodes, all you have to do is turn on this plugin. So you can see by default on this head node, we have a bunch of plugins. One, Cronny, to manage the system's NTP information. Cloner server, so this is set up as a cloner server, so this is the machine that will store the images to clone out to nodes. The DHCP DNS server, so we'll manage DHCP and DNS across the cluster. File sync is a plugin that allows you to pick individual files to sync across the machine. FSTAB, we manage the Etsy FSTAB on the nodes. So this is useful if you want to create NFS mounts, things like that. You can do that directly within ClusterVisor. Hosts, we manage the Etsy host file. LDAP auth, we're actually using our internal LDAP authentication. So we turn that on and that's enabled. Networking, so we manage all of the networking settings, all the individual interfaces, etc. NFS server, we're providing NFS exports on this node. This is also a file server as well as our head node. Resolve.com, so we're managing the name servers. Syslog, Slurm server, as we mentioned earlier. So this means that this is going to configure Slurm from the server side. SSH, it'll maintain the known host file for you. Sudoers, so it can manage that for you, and also the time zone. So all of these individual plugins are enabled, which means that ClusterVisor will maintain and manage all of these settings for you on this particular node. So if we go ahead and click edit, we can start to see the UI and how you edit all these individual values, and where some of these plugins start pulling their data to figure out how to write their config and set everything up appropriately. So under the General tab, we have some very basic stuff. Before we get there, I want to give you an idea here of the way the plugins work, in that there are tabs here that don't have a little plug on them. If they don't have a little plug on them, it means that these are kind of global values that are needed no matter what. If they do have a little plug on them, that means that they are plugin specific settings. So if we were to turn off the NFS server plugin, this tab would disappear because we don't need any of the values in that tab. So on the main tab, we have basically name, groups, so you can kind of group nodes together. A few other options here, the status. So if you decide you're going to temporarily take some nodes down or permanently take them down, you can actually use the status to do that. And if you don't want to delete their configuration, SSH keys, serial numbers, that kind of stuff. This is the head node, so it doesn't actually clone or boot a network, so these settings don't apply a lot, but the networking tab does, and I think that's kind of the start of a useful thing. So you can see we can define all of our individual Ethernet devices in here. So for example, under EN0, we can define, if it's enabled, the boot protocol, the host name, IP addresses. If it's in the firewall zone, you can even define the switches and which ports they're connected to, etc. So I don't need to make any changes here. But if we want to add a new interface, throw it in here. We also support fabric interfaces like IB, so we'll set up the IPO-IB interface, and then also IPMI interfaces. So if this system, again, is VM-based, so it doesn't have IPMI, but if it did, you can enter the channel. So if it uses IPMI LAN channel 1, you can go in here, put all the information. You can actually tell it to manage the user for you, and the IPMI user to ID, username and password, and would automatically create that user on this node for you. So when you have the IPMI interface stuff enabled, this provides an easy gateway into ClusterVisor managing power control and things like that through IPMI. So the rack tab defines which rack this node is in, the position, the size of the chassis in rack units. We'll get to that in a minute. The stats are which graphs and computed stats are going to be available on this node. And then we'll kind of move into a few of these plugins, and you can see where we can see this cronny is going to be a time server, and here are the hosts that it's going to sync its time to. It's going to be a cloner server. This is where it's going to store the cloner images. DHCP, we're going to set our upstream DNS server. Under DHCP, we set the subnets that we want to hand out IP addresses on. It also supports TFTP for network booting. File sync, again, this is if you wanted to actually have ClusterVisor manage files, a few files across the cluster for you. For example, if there was a configuration file that you wanted to stay in sync across all the nodes, but we didn't manage that for you, you could add that file in this list here. FSTAB is if you wanted any external mounts. On the head node, we don't, but under NFS server, you can see where we're actually exporting two different file systems. So this will manage all your NFS exports for you without having to edit any of the config files. Syslog, we set it to be a mode of server. So this head node then can receive logs from all of the compute nodes. And then under Slurm, we can start to see some information here. We'll go back to that in a few minutes when we get into that. And then there's also sudoers. So you can actually manage which users can run certain commands, all of that kind of stuff. So you can totally manage all of that from the web interface. So if we look at the node real quick, we can see there's a few less plugins enabled. It doesn't need to run a DNS server, DHCP server. It doesn't need to run NFS. It doesn't need to run Slurm. So there's a few less plugins here. But if we hit edit on that, we can see a few more options because this is a multi-set of nodes. So this configuration we're viewing here is for node 01 through 05. So all of the settings in here will be the same for all of the nodes. So you can see we have a name of 1 through 5, so we have 5 nodes defined. They're in the groups nodes and compute. You can create arbitrary names to group nodes together if you'd like. They're currently all active. Now, these little pluses on the side start to play in when you have these multiple node setups. For example, so let's say node 1 through 5, they're all active, but let's say by chance node 3 has some hardware failure and we want to temporarily deactivate it. So you can click this plus sign here, and now we get an additional field for the same status. So we can go over here and say it's temporarily inactive and change this to node 03. So now node 1, 2, would be active, node 4 or 5 would be active, but node 3 would be set as temporarily inactive. So this is a way you can override just one setting on a particular node or a handful of nodes without having to break this into multiple pieces, and still have the nice ability to edit them as all one chunk. I don't want to do that, so I'm going to go ahead and delete that. So again, the networking is here. One of the things that we offer is the ability to do some variable substitution here. So this is the Ethernet 0 or EN0 device on node 1 through 5. So we wouldn't want them all to have the same IP address. So if we do 10, 10, 1, $, curly bracket underscore index, the word index here, this variable, will be replaced by the number. So node 1 would have the IP address of 10, 10, 1, 1. Node 2 would be 10, 10, 1, 2, etc. And then name becomes the fully expanded name here. So for node 1, that would be node 01. For node 2, it would be node 02, etc. So here you can start to see where we use some of the override values so that we can have individual MAC addresses for each node. So again, the plugins are very similar. This time, for example, the FSTAB plugin, we go in here and say where we want the NFS mounts to come from. In this case, the syslog, we're a client, and our syslog server is the head node. In this case, we're also a Slurm client. So in here, we go ahead and define all of the values that we would normally define inside of Slurm, how many sockets, cores, threads, memory, etc. This will automatically configure Slurm. If you do have any grezes, like GPUs, you would also kind of define them in here. So that's the basic node definition. So if we wanted to add a new set of nodes, you could copy this to create a new set, or you can type a new one. So let's say we added some GPU nodes. So you could call this GPU 1 through, let's say we had 4 GPU nodes. You click there, click add node. Would bring us a new dialog box. We can fill out all the information about the networking, the rack, boot information, what have you there. So to make it a little easier, we'll just hit copy, and we'll call that GPU 01 through 04. We're going to put it in a group. We're going to leave it in the group nodes, but we're also going to put it in the group GPU. And the networking, we're going to go through here. And so in this case, this was going to be GPU node would be 10.1.1.1, but we already have that. So we're going to go ahead and do a little bit of math here and just do an offset of plus 10. So now GPU 1 would be 10.1.1.11, and GPU 2 would be 10.1.1.12, etc. I'm not going to fill out all of these. I don't have, I'm not really adding nodes, so I'm not going to change the MAC addresses here, but I'm just going to go ahead and change these all real quick. Okay. So I'm going to go ahead and leave everything else basically the same for now, because not much else really needs to change. If I hit save, you can see that there are not only nodes 1 through 5, there's GPU 1 through 4. And you can see the other thing that happened, this big red button turned, or this button at the top turned red. So when you make a change like that, that would change things across the cluster, your settings would have an impact. We don't immediately go and change those settings on the nodes. We want you as an administrator to have control over those settings. So that's what turning this button red does, is indicates to you that there are changes in the queue that are ready to be committed to the nodes. But when you're ready, you can commit them. So if we hit this button, what we'll see is which plugins are going to be running on which nodes because of the changes. So you can see that on our head node, we're going to be changing stuff to DHCP, host, resolve.conf, SSH. All of these different files will get changed because of us adding nodes 1 through 4. So if I go ahead and hit commit changes to nodes, so you can see the button is no longer red because the changes have been committed. So if we pull up our terminal here and we'll log into node, our head node here, if we look at our host file, you see that ClusterVisor has already updated the host file and defined GPUs nodes 1 through 4 that were not there before. So it's an easy way, as you can see, to manage the nodes in your cluster. Now that we know, we don't have GPU 1 through 4, we want to get rid of them. We can go ahead and hit delete. Delete that. We'll delete the entire section out of the database. Changes will need to be committed to the nodes. We commit the changes. Now, if we look at the head node here, you can see that GPU 1 through 4 are no longer in the host file. And that's also the case if we log into node 01 of the cluster and look at the host file. You can also see GPU 1 through 4 are not there. So by making one simple change inside of the web UI, you can see we've made a global wide change across the entire cluster. All right, so our next section we want to move into is these other tabs. So we've got a bunch of other tabs. Netboot here. I'm not going to spend as much time on the rest of the tabs, but just to give you some details of what these are. The Netboot tab here is what different networking network booting options you can define on the nodes. So if you want a node to boot for its local hard drive, if you want to run our cloner utility, if you wanted to, you could add other things in here. And then inside of the node, you can define how the node is going to boot. Cloner image is the storage of the actual images. So it gives you some data. If we click on edit here, you can see there's some different values if we want to grow the last partition, if we want to store attributes and ACLs, what kind of options, there's scripts that can be run, etc. So all of that can be stored in here. One of the things, if anyone here was familiar with our last set of utilities, Cloner would store an image and the disk layout as one unit. In this version, we've split those into two separate units. So the idea is that the disk layout would have the partitioning information, RAID arrays, LVMs, where things are mounted, etc. And that is divorced from the actual data that is applied to said disks. So this allows you to have one image that may be deployed on quite a few different types of nodes with different disk configurations. So that's what the Cloner Disk tab is, your disk layout. And you can see here in this example, we have one disk of SDA. If we click on that, we can actually see the individual partitions and their sizes. So we can actually see which bootloader is being used. We support both grub and MS-DOS disk labels like and grub, as well as EFI booting and grub EFI. And here you can see the different mount points. So when you look at a node under the booting tab, you'll have to pick the individual image that you want to install on the node, as well as the disk layout. So this gives you a lot more flexibility in being able to reuse one node image across lots of different types of hardware. Cloner BIOS, for certain types of hardware, we can actually automatically set BIOS settings. It's kind of an advanced topic, so I won't go into it here, but if you did want to have every time a node was cloned to automatically make sure all the BIOS settings were where you wanted them to be, you could put that in here. Diskless Image is similar to Cloner in that we can create an NFS root mounted image and that the nodes can boot them without having local hard drives. So again, more of an advanced topic we don't really have time to go over today, but if you're interested, let us know and we can give you some more information on how that works. So switches. So if you want to define all the switches in your cluster, we can call it, let's say we have an Ethernet switch. So we want to call it Ethernet. You can put it in here, the type of switch it is, Ethernet and InfiniBand, the omnipath, the number of ports, the model, serial number, the networking configuration. If you put all of this information in, it will add it to the host file, sever everything up for you. You can also put the rack information in here, so that way it will be part of your rack diagram. Miscellaneous device is for any other device that you would like to add into the host file and for ClusterVisor to know about, but it won't necessarily manage. This would be things maybe like network monitoring devices like temperature sensors that are Ethernet connected. Again, anything you want ClusterVisor to edit the host file for, manage that, maintain that for you, you can add them as miscellaneous devices. So racks, you can define racks. And again, it's rack 1. We've got 42U rack. It's in row 1, column 1. So the rows and columns allow you to kind of arrange your racks in multiple rows. All of these inputs here do support the expanded syntax though. So for example, if you had 5 racks in your cluster, you could do this, and then you could change the row to be 1, but the column to be index. So now you would have 5 racks by adding 1 entry instead of having to add 5 individual racks. It's just a nice quick way to reduce the amount of data entry you need to do. Chassis are for multi-node chassis that have Ethernet on them. We have some models of systems that we sell that do this, and this is a way to add that chassis. In those cases, that chassis has its own IPMI interface, so that way you can actually manage that. It's also for any multi-node system, even if it doesn't have IPMI, for rack layout purposes. So if you have a 2U4 node, which is the example we have here, you'll see it in the diagram here in a few minutes. Graphs. This is a ability to create custom graphs inside of ClusterVisor. Again, this is more of an advanced topic. It does require a little bit of InfluxDB SQL code, but it will allow you to create your own custom graphs. Dashboards, we'll get into those in a second, as well as monitoring rules and computed stats. The sync files is where you maintain that list of files that you would want to sync if you had other files you wanted to sync. So that's kind of the real quick overview of the configuration section. Again, if there's more details or questions you have on this, we're happy to have a one-on-one conversation with you afterwards and give you details or information about how this all works behind the scenes. But with that, we're going to move on to the other tabs here on the side of the ClusterVisor interface. Okay, so we're going to move on to the dashboard section of the ClusterVisor interface. This is the main screen when you pull up ClusterVisor. It is a information at a glance page where you can create these custom tables and then graphs and other information that you want to show about the status of your cluster. As you can see across the top here, we have a dashboard. This is a drop down because you can create multiple dashboards. We're just called this one Overview. And then you also have a series of tabs here. And again, these all can be customized in the configuration section. So you can create tabs about certain metrics or information that's important to you, create separate dashboards, etc. So in this dashboard, we have a summary page here where we have 2 separate tables. The first table are the nodes that are in error state. You can see there are currently no records to display. So yay, we don't have any nodes in error state. And then we also have this other table called the most recent stats from all nodes. I'll go ahead and click on these other graphs or these other tabs before we come back to this. So on the node CPU graph or tab, we see we have some graphs, and it's the CPU frequency of all the individual nodes. And again, all of this is completely customizable, so you can choose which pieces of information you want to display. In this graph here, we have utilization across the entire cluster. So this is kind of aggregate graphs. So you can choose whether you want individual node specific graphs, or if you want aggregate graphs, or if you want tables of information, or any combination of. So the tables give us some nice abilities where you can sort them, you can search for them, you can show certain quantities. It's also clickable when you click on an individual node. But first we'll get into, you can see there's these individual stats here. So we have the CPU utilization, the load average, memory swap, temperature. But if we go ahead and click on a node, so we get a pop-up here of all these separate tabs for details on a specific node. So in here we can go to graphs, and we can see all of the individual graphs of that particular node. So we can see the load average over time, we can look at disk information, we can look at fan speeds, we can look at temperatures, voltages. Again, all of this is completely customizable. We can also look at this all stats tab, which I think is kind of useful here. And so these are all the statistics that are currently being gathered from this node. So it's a long table of stats. Depending on the hardware you have, you'll have more or less statistics. So this again, since it's a virtual machine, only has 98 records. In physical hardware, where you have RAID cards and IPMI and InfiniBand and other pieces of hardware that we collect stats on, there can be hundreds and hundreds of individual stats you can monitor. So if we do look at our table, though, we've got this nice, average of CPU temperatures here. But one of the things that maybe I want to monitor is, let's say, the inlet temperature of the machine. So that way I can see if maybe my data center has some issues. So what I can do, I'm going to go ahead and alter this table. So I'm going to go to the configuration section and go to dashboards. And you can see we have this one dashboard called overview. If I click edit on it, and we have a couple of tables. And here we see this one table that is most recent stats from all nodes, which is the table I want to edit. And you can see there's some setup information, some title, where it's getting names, what tab it's under. But here is the individual fields inside of my table. So we have CPU temperature, we have swap memory, just what we saw on that table. But let's add a new field. So I want to add one called inlet temp. So if I knew the name of the stat, I could just type it in here, but they're kind of long, so I can just hit the lookup table here, and then I'm going to go ahead and type in inlet to help me. And you can see a lot of these temperature values, we're not only reporting the value, but if there's an upper or lower bounds. So in this case, we just want the value. So we click there. And the format, we want it to format that piece of information as a temperature. And on the summary, which is at the bottom, let's say we want the average. So if we hit close, and now we hit close again, and we save our dashboard. Now if we go back to our dashboard, you can see it's now been expanded, and we have this new column called inlet temperature along with the averages. So it's a really quick, easy way to show, again, whatever stats are most useful to you. So you could have multiple temperatures. You could create different tables. So if you wanted to create a tab at the top called temperatures, where you had a separate table of just the important temperatures, you can do that, completely customizable to whatever you'd like. So we're going to move on now to the rack layout tab. So the rack layout tab is a pretty basic rack layout view, but it does allow you to kind of see your cluster as it would be in the data center. So again, when in the configuration you saw that the racks was defined, you can also see the individual nodes. Again, all the nodes become hot links, so if you click on one of them, you get the information about that individual node. You can actually choose a statistic to show here in the rack layout as well. So if you wanted to see the CPU temperature, so we can actually start plotting certain values in their physical layout. We find this to be interesting sometimes to see if there's hot spots in the rack or some cooling issues. It's an easy, quick way to kind of at a glance see that. So device details is the same screens that we saw on those pop-ups. So we'll go over that a little more detail. So you can choose to see device details from nodes, switches, and chassis. Currently we only have nodes defined here, but if we look at our node here, we have a couple of tabs. We have monitoring, and these are the individual monitoring rules. And we'll get into that now. So you can see we have two rules created. One that is a late check-in, which means the node hasn't sent its stats in over 120 seconds. And you can see the current value is 11. So it's been 11 seconds since we last got stats from the nodes. So that's not greater than or equal to 120. So therefore, the status of that monitoring rule is good. Same with this is a high temperature alert. So we can see that if the temperature is greater than 60, it would be in an error state. Well, it's only 50, so we're good. So these individual monitoring rules can be set up again in the configuration under monitoring rules. And you can see the name of the rule here, late check-in and CPU high temp. Let's look at the CPU high temp. So in here we can see which fields we want to monitor. Again, 50 degrees, and then we can actually create email addresses here. So if we were to put in some email addresses, then it would automatically send out notification when these values go above their value. Or you can actually run scripts as well. So if you wanted to, for example, shut a node down when the temperature hit too high, or take it out of Slurm, your scheduler, something like that, all of those are possibilities. So if we go ahead and click here on the field, I want to show you what happens. So I'm going to go ahead and change this value to 50. So if we change that value, hit close, hit save. So if we go back to our dashboard, now we can automatically see that now we actually have nodes in error state because we have some of the nodes here. It'll take a second here because it's on update of data. And we'll start to see more nodes. All of the nodes eventually will show up probably because they're above 50. But you can start to see the errors or nodes in an error state. And then if you click on them, you can actually look at the rule and see the reason that they're in the error state. So again, quick, easy way to create kind of rules and limits and monitoring of your cluster. I'm going to go ahead and change that back to 60. And again, we just go in here, change our rule back to 60. And you can create as many monitoring rules, so you can monitor things like when RAID cards are in the error state, or when temperatures are out of bounds, when load averages are too high, whatever rule, whatever piece of data that has been collected, you'll be able to create a rule on and monitor. So boot and power control is just a quick, easy UI way to manage the power. So we can choose which node we want to manage if we click all of them. So we can see the SSH status. These machines don't have IPMI, so eventually it'll time out here. But if you wanted to shut down or reboot nodes, you can do that quickly and easily from this interface. Execute command is a way to run commands across the nodes. So I can choose which commands or which nodes I'd like to run across or which groups of nodes. I'm just going to select all of them, and I'm going to enter the command uptime. If we hit execute, you can see now it runs across all the nodes and gives us the output of those commands. And you can continue to run additional commands here. So all from a web interface, easy way to run parallel commands across the nodes. Configuration, we've already been there and spent quite a bit of time there. So we'll skip that. Users and groups. So this is a full user management. So here's my user here. We can see my UID, GID, home directory login. We also allow you to put in lots of other additional information in here. Also, if we want to change this user's password, just hit the password button. Adding a new user is as simple as typing the username here, filling out a few fields. Groups work in the same way. You can choose which users are part of which groups. When you add users and groups through this interface, they're automatically available on all the nodes, as this alters the ClusterVisor's built-in LDAP system. Log viewer is just a nice front end to kind of see log files on nodes, so you can kind of look at the individual syslog, some different ClusterVisor specific logs. So here you can see a while ago on May 20th, we were rebooting and cloning these nodes, and you can see all of the different statuses of recloning all of those nodes. So it's a nice, easy way to see all of that. Terminal is just a convenient front end to bringing up a terminal on individual nodes. You can actually do it on multiple nodes, flip between them. So a nice, web interface to doing that. So now I want to flip over to the command line for a second and show you some of the command line tools that are also part of ClusterVisor. So if we're logged into the head node, all the ClusterVisor commands start with CV. So if you do CV, you can see there's a whole series of commands here. So there's CV conf, there's CV copy, CV diskless, CV exec. We won't have time to go through all of these, but I'm going to go through a few of them just so you can see how this works. So the CV conf command is the equivalent to the configuration section in the web UI. So if we run CV conf without any arguments, it gives you some help information. But I'm going to run CV conf-sa, and that's show all. So this shows us all of the entries in the database. So you can see we've got all the individual config sections. We have the node, the individual nodes here. We have our dashboard is in here. There it is right there, our overview dashboard. So we can edit any of this from the command line as well. So if we wanted to edit our node, let's see this node here. So we can do cvconf-e node-node 01 through 05. So what gets pulled up is a YAML interface to the configuration that's in the web interface. So these are all the same fields that are available there. So you can go through your editor and change any of these that you'd like to. At the bottom, it automatically self-documents and gives you an information of all the different fields that are available to you, what the valid values are, the same help text that's in the web interface as well. So for example, we can go in here, and if we were to change our Slurm settings, we could change a number of sockets by just changing a value in here. So if we wanted to change a particular IP address or MAC address, it's all available to us in this this command line interface. So quick, easy ways to change from the command line if you don't have access to the web browser or don't like using a web interface. Still completely doable from the command line. So the other commands like cvexec is a tool to run commands in parallel across the nodes. So if we do cvexec-in node 04 uptime, we've run the command on node 4. It does take the same kind of syntax as, and this will run the commands on node 1 through 4. It does run those in parallel. So if you're running lots of things across multiple nodes, you can do that. It also supports a group syntax. So we did create a group in the configuration called nodes, so you can do that. There's lots of options here. There's also a cvcopy command. So if we wanted to copy, so if we were, for example, run cvexec-g nodes ls temp test file, we're going to get an error on all 4 nodes that temp file doesn't exist. So if, let's say we have a file on our head node here and we make one. So we've got a file now called test file. So if we run cvcopy-g nodes temp test file, oh, we have to put the destination. So what this is doing is saying we want to copy this test file from the local machine to temp test file on all the nodes. So if we do that, and now we run our exec command again, we can see there is now a test file on all the nodes. And it's just as simply, we can do cvexec-g nodes rm temp test file. And now that file is now gone on all of the nodes that are defined in the group nodes. So there's also the cvcloner command. So this command is useful to create images, create disk layouts, send those to the server, do multicasting of nodes, installations, even updating settings and things like that. So that's quite a lengthy set of commands to go over, so we don't really have time to do that right now. But again, if you're interested, we can give you a in-depth demonstration on that as well. All right, wrapping things up. Currently, ClusterVisor supports Red Hat Enterprise Linux 8 operating systems that include CentOS and Red Hat. Other operating systems are being evaluated. If you have a need or demand, let us know. We'd love to get feedback on that. It's also currently included for free with the purchase of a cluster from Advanced Clustering. There's no ongoing license costs or support costs. It's part of your purchase from us. It's also under active development with new features like Slurm accounting and job analysis coming soon. We'd also love your feedback if there are other features you'd like to see added. We're always eager to hear. And if you want any more info, you can check us out on the web here at this advancedclustering.com/product/software/cluster-visor, or you can contact us at info@advancedclustering.com. Again, we appreciate your time. I hope this was helpful for you, and have a great day. Thank you. Okay.
Looks like I had some mic issues. So now I'm going to go over any questions. If there are any more, feel free to submit them in the chat. Looks like we do have one right now, and it is, what is the it looks like this is HTTPS, and what is the authentication from CV to the nodes? So yes, it's HTTPS to the Cockpit interface. You can certainly add your own SSL certificates there. The communication from the Cockpit server daemon to the client daemon is encrypted with Munge. We use the same encryption that Slurm uses, so there isn't a need to manage SSL certs across the nodes. So hopefully that answers your question. Any other questions? So then, yeah, we do have another question here. It's about with CentOS being discontinued. What are the plans to offer an unpaid, unsubscribed OS? So obviously that's still a pretty fluid set of events. So we are looking to see where the market takes us with that. Like I said, we currently also support Red Hat. There are multiple projects that are trying to replicate what CentOS 8 does. We certainly plan to support those. But if the market demands moving to Ubuntu or Debian-based distro or anything like that, it would be a pretty easy transition for us as well. So we're staying pretty open and seeing what happens there. So I got another question here. Is Cockpit running on the other nodes or just the CV client? So Cockpit only needs to run on the node that is running the web interface. And it is absolutely not even required. So if you don't want to use the web interface and only want to use the command line stuff, you don't even need Cockpit. So the only thing that runs on the node is CV client D, which is the daemon that manages the node. Okay. Well, that looks like about all of the questions. So, if there's nothing else, we'll go ahead and end the session. And as Wade mentioned in the beginning, you'll be getting an email with information on how to download the sessions and the slides, as well as a recording of this. So again, thanks for your time today, and have a great day.